Hey everyone, today we're going to take a look at the so-called ProductSum method, which is a way of factorizing which we haven't taken a look at yet. And to introduce you with this method, I'm going to start giving you some mathematical riddles. And you will think, well, how will this help me? Well, answering those questions that I'm going to ask you will help you a lot when you're going to use the ProductSum methods. So we're going to start with a riddle like this. Which two numbers have a product of 18 and a sum of 11? Think about this for a moment. Some of you will find this very quickly, some of you will need a bit more time. If you do this correctly, there is only one answer that you can give here. Are going to be the numbers 2 and 9, because 2 times 9 is 18 and 2 plus 9 is 11. It's going to be important to think about riddles like this. So I'm going to practice a few more with you. So let's say Julia has more questions for Stanford. Can you figure out the answers? Which two numbers have a product of 20 and a sum of 9? Of in Nederlands, welke twee getallen hebben een product van 20 en een som van 9? There is going to be only one answer here. The answer is going to be 4 and 5, because 4 times 5 is 20, while 4 plus 5 is 9. Do this for a product of 20 and a sum of 21, and you will find the numbers 20 and 1, right? And you can do this for C and D as well. C will give you 2 and 10. And the last one gives you a negative number as the sum. You have to be a bit more crafty here. Here you have to find the two numbers minus 2 and minus 10. Because minus 2 times minus 10 is not minus 20. Mistake on my part here. It's going to be positive 20, which is the number that we're searching for right here. And minus 2 minus 10 is going to be minus 12. So I should find the numbers minus 2 and minus 10, okay? Well, we're going to use this method for cases like this. Remember, if you have something like this with brackets, we learned that we can multiply out the brackets here using the so-called parrot's beak methods. Well, that's how I called it, right? I said to do x times x plus x times 5 plus x times x, plus 3 times x and 3 times 5. Gives me x squared plus 5x plus 3x plus 15. Add up the like terms will give me x squared plus 8x plus 15. So if I'm going to skip the intermediate step, I can also write it down like this. And I want you to now very carefully take a look at the colored numbers. We have the two red numbers, the blue and the green number. Can you find something peculiar about the values of those numbers? Well, if you take a quick glance, maybe you found that the blue number is the sum of 3 and 5, and the green number is the product of 3 and 5. Hey, sum, product. That's also in my name, right? The ProductSum methods. The only thing I would change here is that they call it the ProductSum methods. And here you find that the number in front of the x, that's mostly going to be your second in your string of numbers, is going to be the 8. This is the sum. And the lone number in the end is going to be the product of 3 and 5. So I would rather have called it the sum product methods. Because this thing is the sum and this thing is the product in that order. The sum is always in front of the x. The product is always the lone number without a variable. So without an x squared or an x in this case. Well, if we can do it, we can also do it the other way around. So I can go from this thing right here to something inside of brackets. And that means I am factorizing again. Because I'm rewriting something with terms, things that are added to each other, to things that are multiplied. So the book is going to do it like this. They say the easiest way of doing this, so in this case rewriting this thing as a product, is first to make the table of 15. Now, why do they choose in this case the table of 15, the tabel van 15? Well, because this last number is a 15, right? So if you're going to use this, you're going to make the table of the lone number in the end, the table of 15. We will see a few more examples in a moment where you're going to make different tables. How does this table work? Well, you start like this, table of 15, you have a T like here, they write down the 15 here. Sometimes I heard some of my Dutch students also call this a T-tabel, because this looks like a T, right? What you're going to do is you're going to find numbers of which the product is 15, and in the last column you're going to write down the sum of those numbers. So here 1 and 15, that's okay, and what I'm always going to do is then also write the negative numbers, because minus 1 and minus 15 also works. Minus 1 times minus 15 is 15. What's the sum? Well, 1 plus 15 is 16. Minus 1 minus 15 is minus 16. Well, why do we do it like this? Well, I want to find the numbers here which are multiplied 15 and of which the sum is going to be the number right here, 8. Here I find the sum of 16 and minus 16, so I'm not done. I have to find different numbers. The next number I think I would take a look at, I cannot do 2 times something because I don't want fractions. I want whole numbers. I'm going to take a look at 3. 3 times 5. In that case also minus 3 times minus 5. 3 plus 5 is 8. Minus 3 minus 5 is minus 8. Now I'm done. Why? Hey, in this row here, I'm going to take a look. 3 plus 5 is 8, and that's the number here. So if I now want to rewrite this as a product, I use the number 3 and 5. And I can rewrite it as x plus 3 and x plus 5. Or, because I get this question a lot, x plus 5 times x plus 3. Remember, multiplication is, you can always change the factors, right? They call this commutative in the first chapter. So you can also say x plus 5 and x plus 3, as long as they both have a plus. Don't change that up, right? Okay, let's practice this again. We're going to factorize x squared plus 9x plus 14. So I want to write this inside of brackets, like this. What should I do? I'm going to search for two numbers of which the sum is 9 and the product is 14. Because the product must be 14, I'm going to make the table of 14. Right, so we're going to make a table like this again. Start with 1 times 14 and minus 1 times minus 14. This gives me the sum of 15 and a sum of minus 15. Am I done? No, because I want to find the sum of 9. Let's try the next one. 2 and 7. And minus 2 and minus 7. Hey, now I'm done. Why? 2 plus 7 is 9. So my sum is 9 for 2 and 7. And the product I already know is going to be 14, otherwise it wouldn't be in this table right here. So what's going to be my factorization? Using the ProductSum method, I find x plus 2 and x plus 7. Or as I said, x plus 7, x plus 2, which is exactly the same. Another example, here they use plus 7x and minus 8. Please notice this minus, you have to use it. This is very important, don't forget this. The sum must be 7, my product must be minus 8. Take a look at this table of minus 8. The first thing I will try is 1 and minus 8. And minus 1 and 8. You see, the book even goes further, but I would have already stopped because this one already gives me what I'm looking for. Minus 1 times 8 is minus 8. Minus 1 plus 8 is 7. Hey, my sum must be 7. So here I find the numbers minus 1, you see it right here, and plus 8. So remember, here the minus must be with the 1 and the plus must be with the 8. Not the other way around, because that gives me a sum of -7, and I must have a sum of 7. So here you could swap them around, but then I get x plus 8 and x minus 1, which is the same thing. And this thing, what we're doing all along, is so-called the ProductSum method, oftewel the ProductSum method. What you're going to do, a small step plan here. You take a look at this thing. You see the 5 in front of the x, that must be my sum. Remember, I would rather call it the sum product method, but whatever. Some mathematicians call it product sum. You have to deal with it. The sum must be 5. There is a minus here, so the product is going to be -14. Make a table. Certainly the first exercise that you're going to use asks you to make a table. If you can do this mentally later on, please don't, because it takes some time, unfortunately. If you practice this enough, you don't have to make a table like this every time. If you do this correctly, in this exercise you will find -2 and 7. So the answer is going to be x minus 2 and x plus 7. So now you have learned 3 ways to factorize. We know putting the common factors outside of the brackets, such as short name for such a thing to do, where you find the common factors in the two terms and those you put in front of the brackets, right? This is 7.2 theory A. Then now we discussed the ProductSum methods, and the last way that we discussed, that was in 7.2c, was the difference of two squares. The difference of two squares is important, I would say that, but you will find that the first two, I think, are more important. Why is that the case? Well, for this chapter, you will see in the last paragraphs there is a way to kind of avoid the difference of two squares, which means not that it is not important. Maybe you need this later in mathematics, right? But for this chapter there is a way around it, and there is not a way around the first two. So practice those. In theory B, they will give you examples on which you have to choose which method you're going to use. Okay? And then the last theory is not really about the ProductSum method. I will discuss in a separate video because of that. Good luck to you all.